Today I want to equip the build script with some accessory features. So here's a quick rundown of the particular things I have in mind. I want to throw in some diagnostic outputs, basically some extra printing to help me figure out whenever something is sort of breaking or I can't figure out why it's doing what it's doing or whatever. The only reason these aren't being printed all the time, of course, is that it would make the output super noisy. So I want sort of a switch that I can turn on and off that turns on diagnostic mode when something's busted, and then turn it off when I just kind of want the thing that shows me what happened in a succinct way. Then I want to work on overrides. So overrides is this concept that I've only added to the previous iteration of the script, and I'm still working on it. It's kind of fresh. And the idea of overrides is we have these little variables that are in the local context. They're in that like local folder hidden from Git. And what I want to be able to do is build scripts that can modify those local variables for a particular build without changing the like actual value that is there by default, right? So for instance, places where this would be useful are if I'm making a packaging script that's going to take my code and build it in several ways, maybe make a binary or a debug build and a release build, or build it for multiple architectures, or cross-compile it multiple times, or build it with different settings or whatever. I might want to be able to change and use that same build. Like I want to be able to use the same build call, but with different default settings that come in from that context, so that it can be built in all those different ways. And that means being able to change the context without actually changing what's in the local folder. Another version of when this can be useful is, so for instance, if I have a meta generator that's going to generate code. Even if I'm building in release mode, the meta generator usually doesn't need to be in release mode because it doesn't usually have to do that much work. And it's better if it just stays in debug mode all the time, because when there's a bug there, it might as well be in debug mode in either case, right? So that's just a couple of examples of why I might want to have an override system for changing the local context for a specific build. And I kind of want to work on how to do a good job at that. A few other things I've got in mind here, helper commands. So these are just, since the idea here is we're going to build scripts that are sort of workflow scripts by using the features in the core BLD script, I want to put in a few things in the core BLD script that'll just be useful to have. Something for like printing the state of the local context, maybe something like the ability to move files around it. I was even thinking of maybe throwing in a helper like zip, so I can make a zip file, although I've never done that before. It might be a bit too far. We'll see if it feels right to do that. But I'm thinking of thinking through some helper commands that could go into the BLD script. And then finally, so I have previously not needed this idea, but I need a wrapper script now. And the reason why is a little bit intricate. Well, not intricate. It's just, it'd take a bit of extra explaining. So I'm going to hold off on explaining why I need a wrapper script, except just to say that calling the BLD core directly is a little bit clumsy the way it's currently set up. You can't really do anything with it, and trying to make it work so that it can be both a method for constructing workflow scripts and something that works on the command line seems a bit wrong to me. So I want to try using a wrapper script so that it can be invoked from the command line. So those are the kinds of things I have in mind. I'm going to try to get through all four of these today. I might not get 100% checked off on all of these ideas, but I want to do a pass over this stuff. I'm going to start with the diagnostic output. This one's going to be fairly fast and easy, I think, because I'm pretty happy with how it turned out in the previous iteration, so I'm mostly going to be copying it over. It's just as I'm copying it over, I'm going to double check that I did everything in the way that I think makes the most possible sense. But for the most part, this is going to be a quick one, so let's do that. Okay, so with that, I have a diagnostic output option. The way it works in this case is exactly the same as I've tried to make everything work in the system, which is that the user can control this feature by just passing that out as an option to the commands. So whenever a command looks at the list of options that have been passed in, it can, if it sees the diagnostics, then it just enables extra printing. While I was working on that, I had a new idea come together in my head about a knot of issues that's coming up next. So first of all, let's go back to this old cleanup to-do list that I started. I can check off the diagnostics output element there. And then the next one down is to think about this unanswered question I have regarding where implicit options should get bound or passed with these commands, right? So like right now, unless the unit command automatically handles implicit options, but everything else you have to pass them in. So they're only implicit in the sense that the BLD core script, when you first run it, gathers them up and gives you this implicit options variable to use. But I don't really like that very much. For one thing, now if I want to change one of the implicit or one of the context variables, like if I change my compiler, I have to update the implicit options variable too. There's like these two different variables, and one of them is just a gathered version of the other set of variables. And so it's kind of a redundant state there. And if I update one, I have to update both, right? It's not a great situation. So the idea I came up with is to turn that variable into a function that just does the gather. So any place where I would have used the variable, I'll just call a new helper command, which is something we are going to start working on later today anyway. So we're just going to make a helper command now, I think. And what that helper command is going to do is gather up all of the implicit options and return them as a list. That way it doesn't have to go into a variable at all. It can just be on demand, gathered whenever we want. And then that'll set us up kind of nice for overrides later when we want to change one of the variables in one of those local context variables. We won't have to modify the implicit options. We won't have to pass it. We'll just modify it, call one of the commands, and that command will automatically see the modified context variable because it'll be relying on a function that does the gather on demand rather than having to like pre-cache the gather. So I'm going to do that first, see what it looks like. We're not entirely sure, this is going to be an experiment. I have my gut feeling is that this is going to make things resolve nicely and set us up well, but we'll have to actually see what happens here. This is an experiment, a new idea. So first up, let's go implement the command and bake it into the command, all the other commands, and then we'll go from there. All right, that's up and running, and with it, we're about halfway to providing an actual override feature for this BLD script. So what we still might want to be able to do is restore variables, but we can already take our context variables and modify them right in the script, and that's pretty great. My previous version, I had to do parsing to make it work, and the way things were going before we made the implicit options change that we just made, there was going to be like fiddly extra variables you had to handle or something weird like that. So now it's just going to be literally you can set the context variable in like directly in your bash script and then make the build call, and it will see the change to the variable and apply it into the build. I think that's going to be pretty cool. I mean, we have to actually see it in action to see if it's actually good to work with, but that sounds pretty good to me. And it involves almost writing no extra code, which is way better than my previous iteration. So that all sounds really good. The only thing, like I mentioned at the beginning, that we're still missing is once you've set one of these variables, you probably want to be able to restore afterwards. For instance, like I mentioned, one way to use this is to always put the debug mode on when you're doing a code generator, even if that code generator is part of series of builds that goes code generator, run the code generator, and then build the final program. If the final program is being optimized, that doesn't necessarily mean that the code generator also needs to be optimized. It might make sense to always pin that to debug mode. So for that script to work well, you kind of want the ability to restore whatever was in the implicit context before you overrode it, right? So I want the ability to do that, and I think that the way I'm going to do it is just throw in another command that reloads the parameter script whenever you call that command. This is a little bit high granularity, or like coarse granularity on the options you have. It might be more powerful if you could ask for specific variables to be restored, or pushing and popping, so you have like a stack of values so that you could like nest these sort of override things. But all that kind of stuff sounds a lot more complicated. This is like one very simple command, and if we can get away with that, if that's good enough, then I don't want to go down any more complicated roads. So I'm going to try this option. It's the simplest one I can think of, and it might be good enough. Give it a shot for a little while. If it is good enough, then we'll know, because we'll never think about it again. If it's not good enough, we'll do an upgrade later. So let's go do that command. Okay, so the overrides plan itself is working. I'll need some time to evaluate if I actually like it, but it's working. I did hit a pretty bad problem while I was testing it out, though, and I can't really ignore it. So the problem I hit is that whenever I called my unit command and it failed, or rather, it called the link command and then the linker failed, the whole script stopped. So if I had two unit commands in a row at the top level, a failure several layers deep was causing the whole thing to stop. That's not really super great, because now the user code has no control over when a failure state means termination and not. It's just out of my control that a single failure means full stop of everything in all possible scripts using the system. I don't love that. That's a little bit it's a little bit of a huge limitation that I could cause a lot of headaches when trying to use the system. So there's also the fact that it's not what I expected to have happen, and I want to stop and get a handle on what's actually going on there and see if there's a way to make it behave differently, and if it's like something I've caused by doing something weird. It could be a bug that I've introduced, or a weird way that I've used a feature the wrong way or something. Maybe the return keyword isn't the right word or whatever. We'll take a quick look at that and see if we can get a handle on it. Before I do that, I just wanted to point out that I noticed another issue, which is going to be a big one, which is that in order to load the local options from my local path, I have to know what the local path is. But right now, the way that I know what the local path is that I just have it hard-coded into the BLD core script. And that's going to make it tough to isolate, because the way I usually parameterize things in the system, the way I usually pass stuff into that script is through the local script, right? So usually I use the local script to put in the extra details. Well, I've only been doing that for context options. Maybe I need a different way of doing it for paths or something. But one way or the other, the point is my original thought, which is that I could just do all of my isolation by moving stuff over to the BLD param script. That's looking more and more like it's not going to work, because you need to know how to find the local script in order to get the whole ball rolling. So that can't be pulled out that way, and it needs to be pulled out. So when I get around to doing the cleanup to do, I already have an element in there for isolation, I think. So I'm just going to put in an extra detail or an extra note to think about this particularly critical detail of the isolation problem. Okay, so with that, it's time to deal with this leaky termination state thing. All right, turns out that was 100% my bug. I used the exit command right here inside the BLD link function instead of return. And what that does in bash is exits the entire bash interpreter process tree, not just the current function, whereas return is just, locally ends the function that you're in. And so everywhere else I did return, which is what I meant to do. Here I was doing exit. I don't know how that happened, but it's not the right thing. So glad that I went and tracked that down. It would have been a thing where later on it would have hit it and I wouldn't have been in the mood because I wasn't working on the script anymore. It would have become a limitation I would just work around and get grumpy with all the time until I ended up, throwing my hands up and saying, this thing's a piece of crap. But we caught it. We've rescued this thing, so hopefully it won't get copy pasted around a bunch with that bug in it again. So, continuing to improve the thing as I iterate on it. It's looking good there. I think what I'm going to do is wrap the episode up here. I've still got the rest of this to-do list, so I'm going to take that with me into the next episode, and I'll keep mixing in this cleanup to-do list in there as well. So see you then.